Hello and welcome back once more. So in today's video I want to discuss just some basics around BGP. BGP has to be one of the most frequently asked questions I get, both from my colleagues and from customers. So I think if we start off with some basic understanding of how it works. Now, the key word here is basics. BGP is a very big subject, so I'm not going to try cover everything off here, just the basic fundamentals. Now, BGP has two primary concepts, one of iBGP or internal BGP, and that's where you have BGP running between devices within a common, what's called autonomous system. So autonomous system is a collection of routers under the same BGP policy, basically, a routing policy or domain. And eBGP is when you are connecting two different autonomous systems from each other, or to each other rather. Now, the things to understand here, the most fundamental basics of BGP, is that between eBGP peers, all routes learned will be exchanged. So every single route learned on BGP1 from its downstream neighbors will be propagated across to BGP2, and vice versa. Anything BGP2 has learned from its downstream neighbor will be propagated across to BGP1 here on the left-hand side. However, in iBGP, routes are only exchanged between directly connected neighbors. Now that's very important. All right, so here, for example, where I have these three devices connected here, I have a loopback on BGP1 and on BGP1-2. BGP1-1 will send this loopback address as a route information update to BGP1. BGP1-2 will send its loopback to BGP1 here, all right? But BGP1 is not going to send 2.2.2 across to BGP1, and nor will it send 1.1.1 across to BGP1.2, all right? The only two ways to get that to happen are: one, we connect BGP1-1 to BGP1-2, then they will become directly connected neighbors, and then routes will be propagated between them. Or we instantiate BGP1 here as what's called a route reflector, and as the name suggests, it will then reflect the routes that it receives from its downstream neighbors to other neighbors. However, there are more challenges involved there, in that just because a BGP neighbor, and this is the same for BGP, iBGP as well as eBGP, just because it transmits those routes or publishes those routes to its neighbors, doesn't mean that it changes the route information. In other words, here we have BGP1-1 sending 1.1.1.1 across to BGP1 over here. The source of this will be .2. BGP-1 will receive 1.1.1 from 10.1.1.2, and it will then send that across to BGP2. So BGP2 will say, okay, I have received 1.1.1, and the next hop for that is 10.1.1.2. But notice that BGP2 here is not connected to that network, only BGP1 is. So how will it then respond to any traffic destined for 1.1.1? Because it can't get to 10.1.1.2. And even if we publish this network across to BGP2, it still won't see that as a next hop. It will just see that as a route existing within its route table. So that is what we're going to, or rather I'm going to try and show you today, how we get around these things. We're going to see the problem in action, and we're going to look at the resolution. And as I said, this is one of the most fundamental challenges revolving around BGP. Now, as I said, this is basics. I can't go through all of this, but what you need to do in terms of self-study is look up BGP attributes. BGP attributes come in two forms. One is a transitive and the other is a non-transitive. Transitive meaning that those attributes are carried from peer to peer to peer, or neighbor to neighbor to neighbor, and non-transitive, as the name suggests, are not carried. So I've set these up here, and to save some time, I've already numbered the relevant ports. All right, so I've got everything laid out here as per the diagram. All right. So here's BGP 1-1-1, 1-2, and they are both peering with BGP 1. So what we're going to do first is we're going to create the iBGP relationship between these. So I'm going to start here because this is effectively the hub. And remember that here we've said that this is AS 65,000. So we put in 65,000. Now, if I don't put in a router ID here, it will simply take the lowest IP and use that as the router ID, and that's what I'm going to do for now. All right. But best practice is to actually use a router ID, and also to use loopback addresses. All right. But I'm not going to go into that, because then that creates more complexity in terms of publishing those loopback addresses to neighbors. So I want to keep this as simple as possible. So now I need to tell it what its neighbors are. So its one neighbor is 10.1.1.2, and the remote AS, because it's iBGP, is exactly the same. Now for now, I'm not going to use any of these other attributes. I'm just going to leave it like that. And then I've got another neighbor, which is 10.1.1.5. All right, just remember, these are on /30, so this is 5. So this one must be 6, so sorry, .6. And again, same AS. Okay, so I'm not going to publish any routes from BGP 1, all right? I'm just going to create the neighborship. So once I've done that, I click apply. Now I'm going to come across here, BGP, and I'm going to say same thing, same AS. I'm not going to use the router ID. I'm going to create the neighbor, which is 10.1.1.1, which is BGP-1. And again, because it's iBGP, I use the same AS. Click OK. And I'm simply going to hit apply there. And you see straight away the neighbor popped up here. And we'll look at that in a moment. And I'm going to come across here, and I'm going to do the same, 65.123. My neighbor is 10.1.1. In this case, it's 5. And I'm going to click apply there. Okay. Now, if I come here, and I do, rather if I come to this one, click apply, open up the CLI, and I do a get router info BGP summary. I can see here that I've got my two neighbors. I can see they're up and how many seconds they've been up for. Okay, it's total number of neighbors. Now, if the adjacency hadn't been formed, it would say never here, because there would be a problem with the configuration, and then you'd need to go off and find out what that problem is. Now, if I do a get router info routing table all here, you'll see that I haven't got any BGP routes here within VRF0. Ignore this, VRF10, I've simply put the management interface into another VRF because I'm using these same subnets elsewhere in my network. And if I had this management network in the same VRF, it would try and route to those via its static routes, all right? So this is just a management container. The important thing here is VRF0. So this is what we're going to be watching. Now what I'm going to do is I'm going to come across here to BGP 1-1. And just to remind you that I've got a what I've called BGP loop here. I've got a loopback address. Okay, so I'm going to publish that. So I'm going to come to my networks and I'm going to go 1.1.1.1/32. Apply that. Okay, so now that should be, well, it won't do it immediately because BGP has also got timers. And here I'm going to, on BGP 1.2, its loopback is that. So we're going to go 2.2.2.2/32. Now again, I mentioned timers. Timers are very important, and if you don't know BGP, I suggest you go off and just do some research in terms of its timers, the way it creates adjacencies. But fundamentally, the default timers is that it'll send a hello every 60 seconds, and it'll declare a neighbor dead after 3 times the hello timer. So 3 times 60 is 180 seconds. So BGP is not about fast reconvergence, right? Was never designed for use in internal networks. It was designed for use on the internet, where stability is very important. Now, there are organizations that use it internally. That's up to you entirely. But then what you find is, because it reconverges so slowly, they then start fiddling with the timers. And then that breaks other things within BGP that were never designed to be broken, right? And that's not to say you can't engineer your way around them. You can, but it's better to use what's called an IGP, an Interior Gateway Protocol. OSPF is probably the best one for internal networks. There is ISIS as well. RIP is a bit dated. That's not to say you can't use it. I wouldn't use RIP version 1. I wouldn't use RIP at all, but if you're going to use RIP, I'd use RIP version 2. And again, I'm not going to go into the differences between these because it's outside of the scope of this. So I've done that. I've hit apply. Just make sure that you do hit apply, otherwise those configs won't take place. Now let's just look at those configs. All right. So remember, on a FortiGate, you can do everything in, well, almost everything in the GUI. But if you want to see what it looks like in the CLI, you can always get access to that, right? So this is very simple. There's my AS. I've created my neighbor, and I've got my network being that I'm publishing there, okay? Now, this is very simple. There are a lot more configuration items within that stanza which aren't being shown right now. So now if we do that again, now what we see is that I have learned those routes from my peers, as you can see. 1.1.1 is coming from 10.1.1.2, and 2.2.2 is coming from 10.1.1.6. So I'm learning those routes. But if I now come along to BGP 1.1 here, and I do a get router info routing table all, you'll see that there's no BGP routes here. Those routes are not being reflected. So they're being sent from here to there, from here to here, but they are not being reflected across to each other, okay? Now, what I can do here on BGP 1 is I can turn this into a route reflector. So I'm going to come along here to both of these, and I'm going to hit that button there, okay? And I'm going to say OK. Apply. And I'm going to do that there as well. Apply. Okay. Now, it's just going to wait for the timer. All right. So if we do a get router info BGP neighbor, here you can see my neighbor is up and established, but you can see that I've got timers there. And there's also something else called a scan timer. Okay, and that's something that is 120 seconds, and that is where BGP rescans its routing tables to make sure that it is everything's still up to date. The other thing to note about BGP is that it runs over TCP, specifically port 179. Okay, so that becomes important when you are dealing with firewalls. And remember that the FortiGate is a next generation firewall. So you know, there may be times where you need to allow BGP through the device, all right? By default, it will accept BGP on an ingress port, and that's what's known as the local in policy. But if you want the BGP to transit through a firewall between two neighbors sitting on either side of that, you are going to need to allow port 179 across, otherwise it simply won't communicate. All right, so let me just make sure that I clicked apply there. I thought I did. Get router info BGP network. Okay, so the reason it's not showing up in the routing table, okay, so again, if I look at the routing table, you'll see it's still saying there's no BGP routes, but if I come along and I actually look at what it's receiving, you can see that it is actually receiving the route. But the reason it's not putting it into the routing table is it can't resolve for 10.1.1.6. It has no idea where 10.1.1.6 is, okay? So one of the most important things with a router, and a firewall for that matter, but specifically here as a router, is if it can't route to something, simply telling it about it, you know, is not good enough. If it can't get to the next hop, nothing's going to happen. Now, of course, I could publish that information here. So if I come to BGP1, because remember that BGP1 has got knowledge of 10.1.1.0 /30 and 10.1.1.4/30. Okay, so let's tell it about that. So let's go 10.1.1.0/30 and 10.1.1.4/30, and I'm going to hit apply there. So now in a few seconds it will start publishing that information down to those downstream devices, and you can see it's got it in the path table here. And let's just look here. Networks. So those networks have been learned. Okay, so there's 10.1.1.0, which and 10.1.1.4. Okay, and now we've got the route. Okay, we've got the route. So here's BGP 1/1, and it says, well, I can get to 10.1.1.4 via that, but notice that the 2.2.2 is still not within the network, because although it knows how to get to the network, it doesn't know how to get to that host. So we need to do something else. We need to change something called the next hop self. The problem with iBGP and next hop self is that this BGP route reflector won't change that attribute. Okay, it's not going to change it. We need to use something else, which is called route reflector next hop self we need to specifically set the route reflector as the next hop self. So what I'm going to do here is I'm going to come along here and go config router BGP. I'm going to config neighbor, and unfortunately I can't do this from the GUI. Edit 10, and I'm going to do set next hop. Now, it's not good enough just to simply use next hop self. We have to use that one, enable. Next, edit 10, my other neighbor, and we do this again, end. Right. Now, again, we just wait a few seconds. Now there we go. Okay, so now 2.2.2 is in the table because now it's being told that it can actually get to that via the hub. And again, if I come to this one and I open up the CLI and I do a get router info, routing table all, okay, so now I can get to 1.1.1. So 2.2.2 is the local one, 1.1, and notice the next hop self is the route reflector. So if I do an execute ping-options source 2.2.2.2, and I do execute ping 1.1.1. Whoops, it might help if I spell correctly. 1.1.1.1. Hey presto, I can ping. Okay, so now my routing is working because I've configured it correctly. The other thing to note, however, is that because the FortiGate is first and foremost a firewall, we need a policy in there. If I didn't have this policy, nothing was going to happen, right? So, and we can show you that. Switch on the logging. If I come along here and I disable that policy, and I come back here, all right? So, never forget about your policies, otherwise things are going to stop working. Now, because you would never normally have an any-to-any allow all on a firewall, all right? That's dangerous. But this is purely for a demonstration, and it's for the routing demonstration, which is why I've done that. But it's certainly not best practice. Let's come back here again. And hey presto, it's working again, right? So don't forget your policies. Okay, that's all well and good, but what I want to do is I want to exchange all these routes. So get router info, routing table all. I want to send 1111 and 2222 all the way across to BGP 2.1, which is over here. So first off, I need to exchange them with BGP 2, right? So now we need to create an eBGP pairing, 650.0.0.0 to 650.0.0.1. So now I'm going to come along here and I'm going to create a new neighbor. And I'm going to say it's 172.1.1.2. And the remote is this time 6. And again, now I'm not going to play with anything else here temporarily. And I'm going to hit apply there. And I'm going to come here. And I'm going to go 65.0.0.0. And I'm going to create my neighbor statement 172.1.1.1, 65.23. Sorry, this should be 1 there. Okay. And I'm going to hit apply. So again, in a few seconds, we will see those appear. So that my neighborship is there. And if I just, and there it is there. Okay, so if I come along to BGP2 now, and I do a get router info BGP summary, I can see that my BGP relationship with BGP1 is now up and running. If I do a get router info routing table, I don't have to do all. If I just want to see the BGP routes, I can just do that, right? So what it's doing is it's telling me how to get to those 10. Now, I don't actually need these. And remember that I just did that just to show you that simply publishing the local routes wasn't enough to get the next hop self working. But these are the ones here that I'm interested in. Okay? And notice that it's saying that the routes are coming from 172.1.1.1, which is correct. Now, the reason it's showing that correctly is because I put in that next hop self. So this function here, that command that I put in, so show router input, show router BGP. Where is it? Oh, it was there by default. I didn't have to put it in. So that is using it is basically sending, it is using next hop self by default within this statement, right? So that's why it is seeing these routes coming across from the correct next hop. So if I come here, all right, because it's eBGP, it's showing that it's coming from the correct next hop. But now, when I send these across to 2.1 now, so now we're going to create a iBGP peering between these two. So 192.168.1.2, sorry, 65001. Okay. And here, BGP 65001, neighbor 192.1.1.1, 65001. Okay, apply. Just wait for that. So that's come up now. Do a get router info. Info routing table BGP. Router info BGP summary. Just make sure that that's up. It is up. Just gotta wait a few seconds. No, we don't. Get router info BGP network. Okay. Again, we've got that same problem that the routes are within the table, but BGP 2.1 has no idea how to get to 172.1.1.1 because that's over here. Okay, so again, what we need to do is we need to change that next hop here on BGP 2 so that all these routes appear to be coming from 192.1.1.1 and not 172.1.1. So what we're going to do is come across here, and in here we're going to change next hop self. Apply. And again, we've got to wait a few seconds. There we go. It's changed, right? So now if we look at my routing table, there's all my routes coming from the correct place. Now let's look at that in the reverse. So remember that my BGP interface here is 333. So what we're going to do is we're going to publish that 3.3.3.3/32. I'm going to apply that. So now BGP2 is sending that over here. Okay, but let's see how BGP1 sees that route. Get router info BGP network. Hasn't come through yet. Three is there. Okay. 192. Sorry, my up arrow is not working. Get router info routing table all. Okay, so that's in there. I'm just waiting for it to propagate across here, and there it is. Okay. So it's seeing that coming from the correct place. Okay. And that should propagate correctly into these other devices. Info BGP network. Okay. The problem is that once again, I don't have the path to 172.1.1.2. So what I've got to do here is on BGP1, in addition to the route reflector, I need to change this I need to add that. I need to add that. I need to hit apply. Okay, so let's check all these routes here. So on BGP2, I'm seeing all the routes coming from the correct place. Okay. On BGP1, get router info routing table all. I'm seeing those coming from the correct route, so 333 is coming from the peer device, and here router info routing table all. And now my 3333 is in there because it's seeing it coming from the route reflector, and same here, and the same there as well. All right, so the next hop self is very, very important, and remember the reason for that is that the next hop self is an attribute that is not modified by default by BGP. It is carried through unchanged, so you need to tell it. Now, on very early versions of FortiOS, the next hop self route reflector command is not there. You have to use a route map to do that, but the next hop self is there. So now I should be able to ping from all the way from here to either one of those. So let's come across here. Execute ping dash options. Source is 3.3.3.3. Execute ping 1.1.1.1. And yes, I can. And 2.2.2.2. And there you go. So hopefully that made sense. Just remember, eBGP, all routes are carried across, but you must change the next hop self, all right, so that the remote devices can resolve for the next hop, so that, as I said, so that the routes appear to be coming from the correct gateway. And with iBGP, you need to set the next hop self route reflector command on the route reflector so that it not only reflects the routes, but it sends them with the correct next hop gateway. So until next time, I bid you farewell. Thank you very much.